Hi everybody. In this video, we're going to look at Maclaurin series. We've been given this second order differential equation, and we need to begin by working out d cubed y over dx cubed. So we need to differentiate this again with respect to x. So the first thing I'm going to do is I'm going to make d squared y over dx squared the subject. And then we can differentiate that. So we'll move the negative 2y and the 2 dy by dx squared over to the right hand side. Now we'll divide both sides by this y term. When you divide the 2y by the y, we'll just get 2. And when you divide this by the y, we'll get 2 over y, multiplied by the dy by dx squared. So now we need to differentiate this again with respect to x. And this will give us d cubed y over dx cubed. When you differentiate the 2 with respect to x, we get 0. And we can differentiate this product using the product rule. If we let u equal 2 over y, or 2 times y to the negative 1, then we can differentiate this with respect to x, and we get u prime. Because we have a y term, and we're differentiating it with respect to x, we need to use implicit differentiation. So we'll differentiate it with respect to y, we get negative 2y to the negative 2, and then we need to multiply this by dy by dx. So that's our u prime term. Our v term will be the dy by dx squared. And now we need to use the chain rule. So v prime, differentiating it with respect to x, will give us 2 dy by dx to the power of 1. But now we need to differentiate this inner function with respect to x, and we get d squared y over dx squared. So now we can use the product rule to finish off this third derivative. We've got the u term multiplied by the dv term plus the v term multiplied by the du term. And now we can tidy all of this up, and we need to multiply out this negative. We'll multiply these two together, we'll write it over y. And when you multiply this negative by this negative, this becomes a positive. And we can write this as 2 over y squared. And we can collect this dy by dx squared with this dy by dx to give us dy by dx cubed. And this will give us our third derivative. For part B, series solution for y. So we're going to use Maclaurin expansion. And this is in a formula booklet. So I'll copy this bit here. So the first thing we need to do, we know that y, when x is 0, is 2. dy by dx, when x equals 0, we're told is 1. d squared y over dx squared at x equals 0. We can substitute these values into our second derivative. So we've got 2 minus 2 over y dy by dx squared. And this will give us 1. And the third derivative at x equals 0, we'll substitute the values into here. We've got negative 4 over y dy by dx. Second derivative, 2 over y squared, and dy by dx cubed. So negative 2 plus 1 half will give us negative 3 over 2. And now we can substitute each of these values into the Maclaurin expansion. So the series solution will have f of 0, which is 2, f dash of 0, which we know is 1, f double dash of 0, which is also 1, and this is multiplied by x squared over 2 factorial. Then we've got negative 3 over 2 times x cubed over 6 factorial. We'll tidy this up and we get y will equal 2 plus x plus 1/2 of x squared minus 1/4 of x cubed. And this is our series solution for y. Okay.